So here we're going to start the calculations for the lab experiment we have just done. And here is the data that we have. First of all, these are the equations for the three reactions that were conducted. And we're going to calculate the enthalpy of the reaction for each of the three. So we're going to begin with reaction A. The data we have says that the mass of solid sodium hydroxide that we have is 2 grams. These are the initial and final temperatures of the water and the solution. So first we're going to calculate the change in temperature, and we're going to do that by doing the final temperature minus the initial temperature. This gives us 5.34 degrees Celsius. Next, we're going to find Q of the reaction. We know that Q of reaction is negative Q of water. So we're going to first find the Q of water. Q is equal to mass, in this case is 100 grams of water, times the specific heat, or 4.184 joules per degree Celsius times grams, times the change in temperature, which we have calculated to be 5.34 degrees Celsius. Now that we are going to put the negative of that here, which is calculated to be this figure, and we're going to find the number of moles of NaOH, which is this. Once the calculations are done, we will find that the heat of reaction A is approximately kilojoules per mole. Then we're going to go ahead and calculate the same for reaction B. So the data we have says that approximately 2 grams of solid sodium hydroxide was used. And here we have the initial and final temperature. And again, we're going to find the change in temperature. If you do final minus initial, again you will get 11.92 degrees Celsius. We're going to use the same formula to find Q. And the mass of water, again, is 100 grams. The specific heat is 4.84 joules per degree Celsius times gram, because this is an aqueous solution. And we're going to multiply that by the change in temperature, which is right here, 11.92 degrees Celsius. Now the heat of reaction is going to be and once you divide by the number of moles of NaOH, you will get Then we're going to do the exact same procedure for reaction C. Here we have no solid sodium hydroxide, we just have 50 milliliter of 1 molar sodium hydroxide aqueous, which is 0.05 mole sodium hydroxide, and we have 50 milliliters of 1 molar hydrochloric acid. If we add 50 and 50 milliliters, we get 100 milliliter of the solution, which is approximately 100 grams, because we're assuming that the density of the solution is 1 gram per milliliter. The initial temperature is this, and the final is 32.05 degrees Celsius. Again, we're going to find the change in temperature, which is calculated to be 6.28 degrees Celsius. We're using the exact same formulas earlier with the heat of reaction. The mass this time is again 100 grams times specific heat is the same, 4.184 joules per degree Celsius times grams, times the change in temperature right here, 6 times 28 degrees Celsius. Now we're going to use that figure and we're going to put it here. And once we divide it by the number of moles, which was found here, we will get this. Now we're done with all the calculations relating to thermochemistry, but we need to do the Hess's law portion. So here we have the 3 reactions. We are expecting reactions A and B to add up to be reaction C. So let's look at our reactants. Here we see solid sodium hydroxide and solid sodium hydroxide here in both reactions, but we want aqueous in our reactant in reaction C. So what we're going to do is we're going to flip this reaction around. That means that we're going to switch the sign of this reaction, of the enthalpy. So the reaction becomes this, product becomes reactant, and reactant becomes product. The enthalpy will change sign, so you just simply, it's the same number, you just multiply by -1. Reaction B we can just leave as it is. We're going to do some canceling so that it simplifies our expression. So here you see solid sodium hydroxide and solid sodium hydroxide. You can cross those out because they're on opposite sides of the reaction. And that's all the canceling we can do. So here, aqueous sodium hydroxide plus aqueous hydrochloric acid makes aqueous sodium chloride plus liquid H2O. So that's our reaction. And what we're going to do is we're going to add the enthalpy together, and hopefully we'll get something similar to this figure right here. So if we do the math, we will get something like -55.06 kilojoules per mole. Now you compare these two figures, -55.1-ish and -52.6-ish. They're quite close, so that means that other than possible experimental errors, these reactions do demonstrate Hess's law.